Okay, for this lesson we're going to learn how to solve systems of equations algebraically using our substitution or elimination methods that we learned in grade 10. So first, we need to remember how substitution and elimination works. So it shouldn't matter which of these methods we're using, we should get to the same answer either way. In the first case, if I'm using elimination and I have the equations 3x minus 4y is equal to 7, and 5x minus 6y is equal to 8. Well, first I got to make these have a matching coefficient for x or y. I'm going to lean towards y, and we'll see why that is in a little bit here. So I need to make the y's match. That means I got to multiply this entire equation by 3 and this entire equation by 2 to give them the lowest common multiple of 12. So when I do that, what I get is 9x minus 12y is equal to 21, and 10x minus 12y is equal to 16. Now that the y's match and they have the same sign, they're both negative, I'm going to subtract the equations from each other vertically in order to cancel out the y's. So if I have 9x take away 10, then I just have a negative x. When I have negative 12y and negative 12y, they cancel each other out, and 21 minus 16 is going to give me 5. So if negative x is equal to 5, then x is going to equal positive 5. If I know x is equal to 5, I need to put that back into one of my equations to solve for y. So I'm going to use the first equation. I'm going to say that 3 times, well, x is now negative 5 minus 4y is equal to 7. Negative 15 minus 4y is equal to 7. Negative 4y, when I add 15 to both sides, is going to be 22. And y is going to equal 22 over negative 4, or negative 11 over 2. This is going to give me a solution of negative 5 and negative 11 over 2. Remembering that the solutions are always going to be in the form of sets of coordinates. Now, if I'm using substitution, I'm going to state that I have the two equations. I'm going to label them. So I'm going to say that I have, this is equation 1, and I'll call this equation 2. First off, I need to isolate a variable in one of the equations. So in this case, I'm going to isolate y, and I'm going to say that in equation 1, if 3x minus 4y is equal to 7, then negative 4y is going to equal negative 3x plus 7, or y, when I divide both sides by negative 4, is going to be positive 3 over 4x minus 7 over 4. I've isolated y in equation 1. I'm going to sub that into equation 2. So I'm going to say in equation 2 that 5x minus 6y, well, now y is going to become 3 over 4x minus 7 over 4 is equal to 8. And now I have an equation in one variable that I can solve. So 5x minus 9 over 2x plus 21 over 2, when I multiply both these by negative 6, is equal to 8. 5x minus 9 over 2x is going to leave me with 1 over 2x's. I'm going to move the 21 over 2 to the other side, and I'm going to rewrite the 8 as 16 over 2 so that I can just combine them. Which means that 1 over 2x is going to equal negative 5 over 2. When I multiply both sides by 2 or divide by 1/2, x is still equal to negative 5. So I'm getting the same answer I did on the other side, which is promising. Because I solved this in equation 2, I'm going to go back to equation 1 and say that y is equal to 3 over 4x, which is negative 5, minus 7 over 4. Y is equal to negative 15 over 4 minus 7 over 4, which is the same as negative 22 over 4 or negative 11 over 2. And I get the same solution, negative 5 and negative 11 over 2. This seems promising. So now I just need to verify it. I'm going to put the solution back into both the equations and their original form to make sure I didn't do something silly when I was doing it. So I'm going to start with the solution in the first equation. I'm going to say that if I have 3 times negative 5 minus 4 times negative 11 over 2, does that equal 7? Well, this is going to give me negative 15 plus 22 is equal to 7, and this one works. Left side is equal to right side. When I put it into the second equation, if I have 5 times negative 5 minus 6 times negative 11 over 2, does this give me 8? Well, 5 times negative 5 is going to be negative 25. 6 times negative 11 over 2 is going to give me 33. And when I combine them, 8 is equal to 8, and the left side is equal to the right side, which means that this solution is correct. If I'm solving a quadratic system, it doesn't change my process at all. It just changes theoretically how many of these solutions I can have. Now, the other thing I need to consider with a quadratic system is that because I can't necessarily isolate just x, because there's still going to be an x squared, like in this equation, I'm always going to be trying to isolate or eliminate y. Because even if I eliminated the x in both of these, I'd still have the x squared and the y, and I don't have that equation in one variable that I need in order to solve it. So I'm going to eliminate y, or I'm going to isolate y in my substitution. Everything else should be pretty much the same. So first off, I'm going to say that I have my two equations here. If I'm using elimination, then I have 3x plus y is equal to negative 9, or I have 4x squared minus x plus y is equal to negative 9. Conveniently enough, the y's are the same. They have the same coefficient, so I don't actually need to do anything here. I can just subtract these from each other. The y's are going to cancel out, so I'm going to get negative 4x squared. I'm going to get positive 4x. And the negative 9 and negative 9 are going to cancel out to actually just make 0. Now I can solve this quadratic equation. Well, they have a common factor of negative 4x, and I'd be left with x minus 1 is equal to 0. As I already know, when I'm solving this, negative 4 can't change what the x values are, but I am going to have the possibilities of, on the one side, x would equal 0, on the other side, x minus 1 would equal 0, so x would equal negative 1. Or sorry, x would equal positive 1. Now, because I have two x values, I'm going to solve for my two y values based on this. So I can split this up and say that on one side, if I use the first equation, 3 times 0 plus y is equal to -9, then y would just equal -9. On the other side, if I had 3 times 1 plus y is equal to -9, then 3 plus y would equal -9, or y would equal -12. And I'm going to write my two sets of solutions. This is going to give me a solution of 0 and -9, and this is going to give me a solution of 1 and -12. If I'm using substitution, then I'm going to take my first equation and I'm going to say in my first equation, if 3x plus y is equal to -9, then that means that y is going to equal -3x minus 9. I'm going to substitute that into my second equation. For x squared minus x plus -3x minus 9 is equal to -9. For x squared minus x minus 3x minus 9 is equal to -9. I'm going to move everything to the left-hand side. 4x squared, well, the -x and -3x give me -4x, -9, and when I move the -9 from the other side across and add 9, they're just going to cancel each other out, and I'm just going to be left with equals 0. And I can factor this down and say that they have a common factor of 4x and x minus 1. And just like we saw in the last case, that 4 isn't going to change things, and I'm going to have two factors, x is equal to 0, or x minus 1 is equal to 0, which means that x is going to equal 1. And then at this point, everything is the same as it was on this side. It's still going to work out the exact same way, because I'm just going to substitute the x's in again, and I'm going to get the same y values. Now, if I'm verifying this, then I'm going to graph this into my calculator, graphing the two equations. My first equation, y1 is equal to -3x minus 9 when I isolate y, and my second equation, y2 is going to equal -4x squared plus x minus 9. You're going to have to change your window settings because obviously this is going to run a lot lower than the other ones have. And then when you graph out your two equations, then you should see something like this. And I get the 2 points of 0 and -9 and 1 and -12.